Okay, morning everybody. This is our second video on relative frequency. If you've got no idea what I'm talking about when I talk about this sort of question, you might want to go back and look at the previous video, the introduction to relative frequency, so that you can understand what I'm talking about here. Okay. Right, so this question is kind of similar to one that has been appearing over the last couple of years, and it is incorporating in the non-calculator higher tier paper a combination of probability and sort of reverse percentages and sort of thinking outside the box. Okay, it would be worth 4 or 5 marks, and it's absolutely fine if you just break it down. Okay, so positive pants on and off we go. So we've got a table here about the colours and the probabilities of taking certain counters. So the probability of taking a red counter is 0.2, etc, etc. Okay. It then tells us that there are 3 times as many pink as green. Okay. Now we're going to put that in terms of x. So if we say green is x, if there are 3 times as many pink, that means pink must be 3x. Okay. Now we know that all of these have to add to 1, so we're going to add up the ones we've got so far. Now don't forget that is 0.20, don't be confused, it is 20%, not 2%. Okay, so when we add those up, we get 0.64. We've then got to take it away from 1 to find out what these 2 missing ones are worth between them. Okay, so 1 take away 0.64 is 0.36. Okay, in total, our 2 missing ones, our pink and our green, have to add to 0.36. So 0.36 is worth 4x because they add up to 4x. So 4x equals 0.36. So that means x is 0.36 divided by 4, which is 0.09. That is the probability of it being green. And so pink is 3x, which is 0.27, 3 times 0.09, okay? Pink is 0.27. So that is 0.09, that is 0.27, and if you added all of those up, you would get to 1. Okay, that's the first bit done. Right, it then says that if 80 counters are red, estimate how many are pink. Now in the previous examples in our last video, we weren't given how many red counters or something, or A colour counters there were. We were told how many counters we have in total. Now here we haven't been told that. We've been told how many red counters there are. Okay. Now the probability they're red is 0.2. Now I've talked to you about writing that as a percentage. So 0.2 is 20%. So 20% are red. So 80 counters is worth 20%. Well, we want to know how many counters there are in total, so we want to know how many 100% are. Okay, so you might want to just go like this. I think this is kind of quite natural for lots of you to do, so I'm just going to do it like this. If you divide that by 2, that gives you 10%. So 100% is timesing it by 10, timesing the 10% by 10 gives us 100%. Is 400, so there are 400 counters in total. Now if you just want to times this by 5, because 20 goes into 105 times, that's fine. I just did it like that because I think that might be slightly more intuitive for some people. Okay, so there are 400 counters in total, and we want to know how many are pink. Well, the probability they're pink, we've just worked out, is 0.27, i.e. 27%. So we've just got to find 27% of 400. Well, 20% we actually already know, we could have worked it out anyway, is 80. 1% is going to be 400 divided by 100, which is 4. So that means 7% is 4 times 7, which is 28. So 27% is adding those 2 numbers up. So 80 plus 28 is going to be 108. So how many pink counters do we expect? We expect there to be 108. Okay, our second example is going to be on one a bit like this. Okay, it says in a group of 45 students, the results of their trip choices are given below. So 45 students were asked where they would like to go on a trip, and these are the results. So 10 want to go to the theatre, 17 want to go to the theme park, 6 to the zoo, and 12 to the beach. In a year group of 360 students, estimate how many want to go to the theatre. Okay, so we need to work out the probability of a student wanting to go to the theatre. So the probability of a student wanting to go to the theatre is 10 out of, well, these all should add up to 45. Okay, because it says there's 45 students in total. Well, let's just check it does. And if it doesn't, then that's my fault and I've written a poor question. But they do, they add up to 45. So the probability a student wants to go to the theatre is 10 out of 45. Now we could cancel that down because we could divide the top and bottom by 5. And we're going to say that is 2 nights. Okay? If I've got 360 students, to estimate how many want to go to the theatre, I need to find 2 nights of 360. Now if you have a calculator, you can just do 2 nights times 360. But if not, we can do 1 night. So that's 360 divided by 9, which you can do in a little bus stop. 9s into 3 don't go, 9s into 36 go 4 times. So 1 night is 40. So 2 nights is going to be 80. So how many we predict want to go to the theatre is 80 students.